Welcome back to Java Internals Crashcasts. I'm Sheila, and with me as always is Victor. Today we're diving deep into the fascinating world of JVM internals, specifically focusing on class loading and linking. This is a crucial part of how Java works under the hood, so get ready for an enlightening journey.
Absolutely, Sheila. This topic is fundamental to understanding how Java programs actually run. Before we start, listeners should be familiar with basic Java concepts and have a general idea of what the JVM, or Java Virtual Machine, is.
Great point, Victor. Now, let's kick things off with a quiz question for our listeners. Here's a tricky one. In Java, when is a class actually loaded into memory? Is it when you compile the code, when you start the JVM, or when the class is first used in the program?
Ooh, that's a good one, Sheila. It's a question that often trips up even experienced Java developers. It touches on the lazy nature of class loading in Java, which is quite different from how some other languages work. I'm excited to see how many of our listeners can get this right.
Me too. We'll reveal the answer at the end of the episode. Now, let's start with the basics. Victor, could you give us an overview of what class loading is?
Certainly. Class loading is the process by which the Java Virtual Machine loads class files into memory. These class files contain the compiled bytecode of your Java classes. Think of it like a library system. When you need a book, or in our case, a class, the librarian, which is our class loader, goes to fetch it for you.
That's a helpful analogy. So, does this mean that all classes are loaded when we start our Java program?
Actually, no. Java uses a lazy loading approach. Classes are typically loaded only when they're needed, which is usually when they're first referenced in the code. This helps to reduce memory usage and improve startup time.
Interesting. So, who's responsible for this loading process? Is there just one class loader?
Great question. There are actually three main types of class loaders in the JVM: the Bootstrap class loader, the Extension class loader, and the Application class loader. Each has a specific role and loads different types of classes.
Could you break that down for us? What does each of these class loaders do?
Of course. First, the Bootstrap class loader is the root of the class loader hierarchy. It loads core Java classes from a special file called rt.jar. Next, the Extension class loader loads classes from the X directory of the JRE, or Java Runtime Environment. Finally, the Application class loader, also known as the System class loader, loads classes from the application's class path, which is essentially a list of locations where your program looks for classes.
That's fascinating. It seems like there's a whole ecosystem of class loaders working together. Now, I've heard the term linking mentioned alongside class loading. What exactly is linking in this context?
Linking is the process that follows class loading. It prepares a loaded class for execution. Linking consists of three phases: verification, preparation, and resolution. Let me break these down.
Please do, Victor. I'm sure our listeners would appreciate a clear explanation of each phase.
Certainly. First, verification ensures the loaded class is structurally correct. It's like a security check. Next, preparation allocates memory for class variables and initializes them to default values. Finally, resolution transforms symbolic references into direct references. It's like turning a name in an address book into an actual phone number you can call.
Wow, that's quite a process. It sounds like the JVM is doing a lot of work to ensure everything is set up correctly before running our code. Are there any common issues or pitfalls developers should be aware of when it comes to class loading and linking?
Absolutely. One common issue is the class not found exception. This often occurs when the required class isn't in the class path. Remember, that's the list of locations where Java looks for classes. Another is the no class def found error, which can happen if a class was present during compilation but is missing at runtime. Understanding the class loading process can help diagnose these issues more effectively.
That's really helpful, Victor. Now, I'm curious about more advanced topics. I've heard about custom class loaders. What are they, and why would someone use them?
Custom class loaders are a powerful feature in Java. They allow you to change how classes are loaded, which can be useful for things like loading classes over a network, generating classes on the fly, or implementing a plugin system. However, they should be used carefully as they can introduce complexity and potential security issues if not implemented correctly.
Fascinating. It seems like understanding class loading and linking is crucial for Java developers, especially when dealing with more complex applications. Before we wrap up, could you share a quick tip or best practice related to this topic?
Certainly. One important best practice is to be mindful of the class path. Ensuring that your class path is correctly set up can prevent many class loading issues. Also, when working with multiple jar files, which are like archives of Java classes, be aware of the potential for conflicts if you have different versions of the same class.
That's great advice, Victor. Now, let's reveal the answer to our quiz question. When is a class actually loaded into memory?
The correct answer is when the class is first used in the program. Remember, Java uses lazy loading, so classes are typically only loaded when they're actually needed.
Thank you, Victor. To summarize today's episode, we've learned about the class loading process, the different types of class loaders, the linking phases, and some advanced topics like custom class loaders. We've seen how crucial this process is to the functioning of Java programs and some common pitfalls to avoid.
Absolutely, Sheila. Understanding these concepts can really help developers write more efficient code and troubleshoot issues more effectively.
In our next episode, we'll be diving into just-in-time compilation, or JIT for short. It's another fascinating aspect of JVM internals. Don't miss it. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue producing this content. Until next time, happy coding.